Moving on to example 2. Notice, I have negative 2a squared b. There's no pluses or minuses in between objects there. That's one full term, negative 2a squared b. That's being multiplied by a squared minus 3b squared. This is two different terms. Whenever you see a plus or minus sign, that's separating terms. So we have term number 1 is a squared, term number 2 is negative 3b squared. Now the technique we have for simplifying this structure is the distributive property. We've already used that this specific chapter, right? The expressions weren't quite as unpleasant as this, but still we distributed before this chapter. So the outside monomial object, negative 2a squared b, is going to be multiplied by the first object, and this is negative 2a squared b to the first. And then I'm going to multiply negative 2a squared b to the first times negative 3b squared. Now, the multiplication happening for each one of those arrows that I've drawn is a monomial times a monomial. So, if I'm doing negative 2a squared b to the first times positive 1a squared, again, looking at what's going on here, negative 2 is being multiplied by 1, that makes negative 2. A to the second is being multiplied by a to the second, 2 plus 2 is 4, so a to the fourth. B is being multiplied by no other b's, so nothing happens to it, b to the first. Then when I do the second multiplication, I'm going to do this one in red, this one. Negative 2 times negative 3 makes positive 6. A to the second times no other a's means nothing happens to a, so it stays a to the second. B to the first times b to the second, 1 plus 2 makes 3. The power to a power thing didn't happen, the negative powers didn't happen, the multiplication is happening, so I went ahead and took care of it right here. Again, there's no division happening, so we don't have to worry about the whole division thing. So that's the final answer. That's the best we can possibly do. Powers don't match, addition, subtraction is illegal. Again, look at the difference in the structures of the two problems, though, to know what to do in which case. One single object, nothing added or subtracted, times another single object, nothing added or subtracted, just carries out multiplication to get one answer. One object times two different objects requires a distributive property, so that gets you two different answers attached by a plus or a minus.